How does it change authentication if we have RSA-style public and private keys to work with? Alice can start out by using Bob's public key to contact Bob and just enter password encrypted using Bob's public key. No one else can see Alice's password. But we've seen this before. This still has the problem that it's susceptible to replay attacks. Eve could intercept this login message and just play the same one again in the future. We could try to mix things up by picking an R every time we contact Bob. So Alice picks an R and mixes that in with her identity and password before encrypting it. Now if Alice picks a different R every time, then Bob should get a different message and that would prevent replay attacks. But a problem here is that Alice is picking R. So in a replay attack, you would be replaying the same choice of R, and so Bob would still go along with it. Another way to view the problem here is that Alice is not proving that she's Alice, and that's why these replay attacks are possible. So we could try using Alice's private key in the mixture here to sign the R that she sends to Bob, and that gives Bob more confidence that Alice is picking it. Well, okay, if we just pick the R on Alice's side and encrypt it, nothing we seem to be doing here is preventing replay attacks. Somehow, the other side has to be choosing the R if you want to make sure that R changes. So let's try again. Let's have Alice just say, I'm Alice, you know who I am, you've got my public key, so pick an R for me. And then Bob can pick an R and send that back to Alice, and then Alice could sign that R, and then Bob knows that he's talking to Alice because she was able to sign an arbitrary R. Well, now there's a problem here because Alice is signing something that someone else gave her. She should not sign an arbitrary R from the internet. How do we make sure that the R that Alice is supposed to sign really comes from Bob? That's where we start using the keys in a good way. So Bob can pick an R, package it up, and say, this R is from me, Bob, and also sign it. Alice can confirm that signature using Bob's public key, and she knows that Bob really did pick the R that she should sign. Then she can sign that R with her private key. Bob knows now that this R came from Alice. Probably no further authentication is needed, and they can communicate. So Alice is signing some arbitrary R that Bob provided, but she trusts Bob not to be giving her a bunch of R's to get a lot of examples of signed values using her private key. And this protocol is how something like SSH gets started. It's a situation where Alice and Bob both know each other, probably because Alice has connected to Bob's service and uploaded some public key there that Bob can use in collaboration with Alice.